A carpenter's son from a forgotten village? No degree, no connections. Before his 20th birthday, he would become England's greatest chemist and discover 6 new elements that make up everything around you. He deliberately breathed in poison, checked his own pulse, and whispered, "I guess this one didn't kill me either." Then he collapsed into a coma for 2 days. When humanity first tamed electricity, it unlocked a treasure hunt that would reveal what everything is truly made of. This is the story of Humphry Davy and the race to discover the elements. I love thinking of science as a game, a playground, and scientists as insatiably curious minds, driven by the sheer joy of discovery. My goal isn't to simplify it. Quite the opposite. I believe this is exactly the spirit science was always meant to have. A playground where the rules change with every era, where some design entirely new games, and others race not to win, but to solve the puzzle, to crack the code, just for the thrill of understanding. And in the 1700s, an entirely new game emerged. A treasure hunt designed by Black, Priestley, and Lavoisier. It was now clear that matter, everything we know, wasn't made of just 3 or 4 elements. Carbon dioxide, nitrogen, oxygen, one discovery after another, and suddenly a race had begun. And the most important figure in this race would be Lavoisier, who, partly following clues from Priestley, had discovered oxygen. Because oxygen was like a kind of glue, holding all the unknown elements together. Strip the oxygen away from any substance, and whatever was left behind might just be a brand new element. And the game had begun. Priestley and Lavoisier had laid the very first stones on the road that would answer the question, what is all of this made of? From the substances they had purified of oxygen, Lavoisier, with his wife's help, compiled a list of every known element. There were 3, and no one knew where this road would end. Back then, even light and heat were still thought to be elements. But, as we said, the game had begun. All around the world, from Sweden to Mexico, from America to Siberia, every day brought a new discovery. For a chemist, discovering a new element was, how should we put it, the equivalent of being the first person to climb Everest. And that's not an exaggeration. One of those who craved that thrill came from one of the most remote corners of England, a place called Penzance, a full week's journey from London by horse and carriage. A carpenter's son, a young man who would become England's finest chemist before he even turned 20. And Science Mosaic viewers know this name very well, Sir Humphry Davy. Remember him? The first mentor of our self-taught genius Michael Faraday, the man who opened the door for him. Even though their relationship eventually soured, we didn't get to talk much about Humphry Davy in that video. So let's get to know him a little better. Let's give him his due. Davy's story wasn't so different from Faraday's. When his father died, he was just 15. He dropped out of school to support his family and became an apprentice at an apothecary. But he was in love with learning. He read everything he could get his hands on and never stopped educating himself. The year his father died, 1789, Lavoisier published his groundbreaking work, Elementary Treatise on Chemistry. And young Humphry Davy read it in its original language, in French. Yes, he taught himself French, just so he could read the latest scientific literature. Historical records show he started taking detailed scientific notes at this remarkably young age. He needed to prepare because he was about to challenge giants. If you want to take on giants, you don't come with simple ideas. You come armed with evidence. In one of his notebooks, he wrote something that shows just how clearly he understood what was happening. Chemistry was born from the illusions of alchemy. Then it was imprisoned by the chains of a fallacy called phlogiston. But thanks to Black, Priestley, and Lavoisier, chemistry is finally free. Through his own self-taught experiments, Davy realized he could disprove one of these giants' theories, Lavoisier's theory of heat. We talked about this in a previous video on thermodynamics. Lavoisier and a group of scientists had proposed that heat was a substance, something they called caloric, an invisible fluid that supposedly flowed into matter and caused it to heat up. Davy, on his own, had figured out that heat was actually the result of motion, the movement of the tiny particles that make up matter. Keep in mind, the atom hadn't even been discovered yet. We're talking about 200 years before atomic theory took shape, and he tried to prove it with a beautifully simple experiment by rubbing two pieces of ice together. There was no invisible caloric fluid coming or going. Friction alone could melt ice. He compiled his supporting research and published his first scientific paper at just 18 years old. This earned him a position as an assistant at an institute in Bristol, one dedicated to exploring whether newly discovered elements could be used to treat diseases. And soon after, he would become the head of that very institute. Let me say that again. All of this happened while he was still just 19 years old? Davy was a little bit crazy too. At the institute, his main job was to produce gases and test their properties. Sometimes he even tested them on himself. Yes, really. For instance, he would inhale carbon monoxide, the same toxic gas that comes out of car exhaust today, and carefully record the results. He came close to losing his life more than once. According to notes from his colleagues at the time, after one self-experiment with a toxic gas, he checked his own pulse and said, "I guess this one didn't kill me either." Those were the last words he spoke before falling into a coma-like state for 2 full days. But this was partly the recklessness of a young man who came from nothing. He knew that to prove himself, he had to take risks. Because Davy identified himself with another English giant. In a notebook from his time in Bristol, he wrote a name right next to his own: Isaac Newton. Davy wanted to be the Newton of chemistry, and he would be. But one of his first major projects would involve using a gas he discovered in the lab to make people laugh. That's right, he had discovered nitrous oxide, better known as laughing gas, and he was the first one to try it. The moment he inhaled it, in his own words, few things in his life had ever been so pleasurable. He started dancing, laughing uncontrollably. Strange, but wonderful. Everyone who heard about this discovery rushed to try it. His close friends from the literary world came and had the time of their lives. Even James Watt, one of the pioneers of the steam revolution, rushed over to try this gas for himself. Science had never been this much fun before, and this was one of the things that made Davy wildly popular. But while Davy was working to turn this discovery into formal science, something was happening on the other side of the world. Something that would change the entire course of human history. A development that would shake the very foundations of science, transform all existing research, and reshape our lives forever. In the year 1800, an Italian scientist named Alessandro Volta announced that he had created a new source of electricity. Electricity? A source of it? What did that even mean? It sounds strange when you put it that way, but humanity only knew electricity from nature, from lightning. Many had died trying to capture it. Nobody truly understood what this announcement meant, but yes, Volta had built a device using copper and zinc plates separated by cardboard soaked in salt water. This voltaic pile, the world's first battery, had tamed electricity. For the first time, it was under human control. Think of it this way. In fantasy stories, there's always some kind of power, and whoever controls it rules the universe. For humanity, this was that moment. But the first waves of the electricity revolution wouldn't excite ordinary people. Nobody could see the potential hiding inside this strange new force. Except for scientists, they immediately began using this brand new energy source to run experiments that had never been possible before. The battery quickly became a tool in the era's greatest competition, the treasure hunt for new elements. Within just a few weeks of Volta's announcement, 2 English scientists used it to split water into its component elements, hydrogen and oxygen. Electricity had somehow torn water apart into its building blocks. Even stranger, hydrogen collected at the negative electrode, while oxygen gathered at the positive side. It was bizarre, yet another mystery waiting to be solved. Of course, Davy noticed immediately. He wrote, "Volta has given us a key to nature's most mysterious force." Before this, our tools were severely limited. Now, especially in chemistry, the possibilities are endless. It's like an undiscovered continent. Right around this time, his work on nitrous oxide had caught the attention of the right people, and this village boy, still just 22, had landed the opportunity of a lifetime. An institution searching for a director for its chemistry laboratory had taken notice of him. The Royal Institution of London. From the wild western edge of England, clawing his way forward, all the way to the Royal Institution, which at the time was the most important center of science in the world. The professors there immediately gave this determined, brilliant young man one of their most important missions: making people fall in love with science. For this purpose, the famous lecture hall on Albemarle Street was built. This building still stands today, still hosts public lectures at the Royal Institution, and you can still watch many of those lectures on their YouTube channel. Its foundations were laid in this very era. At first, Davy assisted the professors, but the professors weren't very good at making people love science. Before long, Davy had become the lead speaker. His gift for speaking, his way of staging experiments like spectacular shows, and a kind of natural stage presence soon had the lecture halls overflowing with audiences. Within a few years, he had gained extraordinary fame, and Davy had set his sights on the very top. Now, in England, there were 2 rival scientific institutions. the Royal Institution, which was more public-facing, and the Royal Society, an exclusive, almost closed circle of the scientific elite. The Royal Society was, in a way, the place for those who had truly proven themselves. And it didn't take long for Davy to earn his place in that exclusive circle. And with a massive battery he had long dreamed of building, he set his sights on discovering brand new elements. After countless experiments, Davy had finally discovered a brand new element. Using electrical current, he had separated a substance known as potash. He had discovered potassium, and he kept going. The very next day, another element, sodium. Scientists who had tamed electricity now held an extraordinary tool in their hands. Before long, Humphry Davy, working alone, had discovered 4 more new elements: magnesium, calcium, strontium, and barium. Meanwhile, new discoveries were pouring in from around the world: boron, iodine, lithium, silicon, aluminum. Don't think of these discoveries in isolation. Just consider how the isolation of silicon alone reshaped the entire world as we know it. I want you to see the butterfly effect at work here. Volta's seemingly simple battery had become an extraordinary tool for chemists. This humble device, the treasure hunt it enabled, it was going to transform the entire world. In other words, developments that seem incredibly simple, technologies we sometimes can't even appreciate, can give birth to changes we could never predict. Humphry Davy himself put it this way: sometimes scientific progress has more to do with the tools we use than with our own intelligence. Nothing accelerates scientific progress like a new technology. But Davy's true revolutionary impact wouldn't be about the elements themselves. It would be about the nature of the electricity he used to discover them. Well, everyone else was using electricity to separate and discover elements. Davy had already started looking at the problem from the other side. Could the electricity that had opened this path for us also have played a role in holding matter together in the first place? Could electricity be an inseparable part of matter itself? Was it the thing holding us together? The force gluing particles to one another? It would take the scientific world more than 100 years to fully understand this. But the fuse had been lit. The story of matter was heading somewhere even more exciting. And in the next chapter, we'll step into the era when this revolution reached its peak. And as always, until we meet again, I'm glad you're here. With love.